I'm Deepak. I'm a computer science PhD student at Georgia Tech. And today I'm going to talk about this work on centralization of the IP layer. So, in this work, I'm going to present the country level consolidation of IP addresses and how centralized is the IP layer. And this work was done under the guidance of Amrish Fakir from Internet Society and Vasilis GSS from Cloudflare. So, why studying centralization is important? Why are we interested in studying centralization? Internet was obviously originally meant to be a decentralized ecosystem, but different layers of the internet are increasingly getting centralized. We know this already. And we also saw in the prior talk how the centralization of the internet is increasingly impacting multiple factors such as internet disruptions. They have become very much prevalent. And the single points of failure. Highly centralized internet infrastructure leads to these kind of risks. Besides this, it also makes it easier for operators or even certain governments to implement mechanisms such as content filtering, censorship mechanisms. But on the flip side, it also makes it easier for certain organizations or operators to implement security measures. For example, it's easier to convince 5 telecom operators to implement security measures than convincing 500 telecom operators. In either case, the centralization of internet infrastructure and resources directly impacts internet resilience. And this impact has to be studied across layers. So, prior work has looked into DNS, web infrastructure, hosting providers, and also into email security. But the IP layer is still poorly understood. We still don't have a very clear understanding of the consolidation of IP resources. So, why is studying the IP layer important? Analyzing the IP layer gives us an understanding into the organizations which take critical operational decisions for IP addresses. So, what are these critical operations? For instance, how to provide connectivity to an IP address. It directly impacts the resilience. How do organizations suballocate their IP addresses? We already know in IPv4 the addresses have exhausted, and right now there's no more additional IPv4 addresses. So how do the organizations with existing allocations distribute their addresses? It brings into question the fair access to IP addresses. Next, routing security measures. Obviously, organizations who manage these IP resources are responsible for deploying routing security measures, and it has direct implications on security. Finally, there's also the end user organizations who are actually deploying services and are responsible for traffic and utilization of the IP addresses. So we need to take a look into the IP layer and the organizations to get a deeper understanding into these aspects. So how do we get an insight into these organizations? So we use the prefix to org dataset, which was published in IMC 2025. So this dataset gives us an information about, for a given IP address, which organization is the authoritative organization, the organization responsible for connectivity, for the allocations, and routing security measures. It also offers us the information about the end user organizations. So which organization is actually deploying services in this specific IP address. To give you an example, here I have this /17 IPv4 address, and this /17 allocation is held by Cogent Communications. Now, Cogent is not using the entire space for themselves, but they have, in fact, for the sub-delegations, in this case, I'm showing 2/24 delegations. And these 2/24 delegations have been given to VMI, ISS Inc. and AppSo Networks. And these are the actual end user organizations. And when we look into IP info data, the country level geolocation data, turns out these two organizations are operational. These two IP addresses are operational in two different countries altogether. So since we are interested in understanding at a country level what is the consolidation of IP addresses, we are using the country level IP info geolocation data. So now that we know the organizations behind IP addresses per country, how do we identify the centralization or the consolidation of resources? To measure the centralization, we use the centralization metric defined in the SIGCOMM paper, formalizing dependence on web infrastructure. To give you an intuitive idea, so on x-axis, we can plot all of the organizations. So each x-axis is one organization, and On y-axis, we are plotting the number of addresses which is managed by this specific organization, which is the observed distribution or the red curve. Now, how much effort will it require to convert the observed distribution into a truly decentralized reference distribution? So it's the gap between these two curves. This gap gives us an idea about how much effort will it require, and higher the effort, the more centralized this specific ecosystem is. And this metric is mathematically very similar to HHI index. And as I was mentioning, lower the effort required, we are more closer towards a truly decentralized distribution, so it's better for us. So now that for a given country, we have identified the organizations with address space, and we also have a quantification of this of how centralized the ecosystem is. Let's take a look into some of the results. In this first plot, for each country, what I'm doing is I'm plotting the centralization of routed IPv4 address space. So obviously, we can notice some of the countries have very high centralization of the IPv4 routed address space, and I'm computing by number of unique IPv4 addresses. So first, we have North Korea. The ecosystem is highly centralized, and the only organization which manages IPv4 addresses is Star Joint Ventures. Next, there are other countries like in Turkmenistan, we have Turkmen Telecom with the highest concentration of addresses. We also have in Algeria, Telecom Algeria, Yemen, Tele Yemen, and Tel Urgu. So what's interesting about all of these organizations is that each of these organizations are state-owned telecom providers. And in some cases, like Algeria and Yemen, these government institutions are the only licensed provider for telecom and internet connectivity in that specific country. And now when I look into IPv6 ecosystem, obviously we also observe certain degrees of concentration. Again, in in African countries like Egypt, we have Etisalat MISL, which has the highest number of IPv6 routed prefixes. We also have Tunisia. And Liquid Telecommunications is this organization which is dominant across multiple countries. Now, what's interesting about these dominant organizations in these countries is that these are not state-owned providers, but in fact, these are private organizations, and their operations often span multiple nations. For example, if we take a closer look into Liquid Telecommunications, turns out they hold the highest number of IPv6 prefixes, not only in one country, but across multiple countries in Central and Southern Africa. And when we take a look at these sort of regional presence, it appears not only in Europe, it doesn't appear only in Africa, but also in Northern Europe, Western Africa, and also in Central America. And this sort of like regional presence of organizations happens not only in V6, but also in IPv4. And now, obviously, when we expand and look into organizations which are not prevalent only in a region, but across the globe, we have Cloudflare, which has IPs in more than 140 countries. And we have Cloud Innovation, which is operational across 123 countries. Even if we remove the Anycast addresses, it still shows up that these organizations have IPs which can be geolocated to a lot of countries across the world. And now Cloud Innovation is an interesting example in this case. I'll give you a reason why. So I took a close look into the operations of Cloud Innovation. Turns out Cloud Innovation has more than 10,000 IPv4 prefixes. Almost 100% of them were allocated from Apronic. But if you look into the operations, they're geolocated in 120 plus countries, but they themselves are not the only users of this address space. They have performed reallocations to 400 plus customers, and obviously they are into the business of IP leasing. And these customers are using almost 480 autonomous systems to originate these prefixes in BGP. And interestingly, none of these ASNs are managed by Cloud Innovation. So Cloud Innovation do not have their own ASN. So they are redelegating all of their address space to other customers. And these customers can be in any corner of the world. and they are using their own infrastructure for their operations. Now, cloud innovation definitely has a footprint in the IP layer. And if you try to perform some sort of centralization studies in BGP, DNS, or hosting provider layers, this organization won't appear anywhere since they don't have any other resources except for the IPs. So definitely looking into the IP layer highlights these organizations which tend to be invisible in other layers, but they still influence the operations. Now, how do centralization trends vary over time? I computed the centralization metrics, and in this plot, I'm showing the trends of centralization per continent over the last 1 year. In IPv4 and IPv6, more or less, the centralization scores do not vary much. They are moderately stable. But we can definitely see that in Africa, the mean address centralization is higher than other continents. And the centralization score in IPv4 is higher than IPv6. One of the reasons can be in IPv6, obviously, it's easier to get allocations. It's easier for more organizations to get direct allocation of IP addresses and have more control over the addresses that have been allocated to them. And hence, there are more players in the ecosystem, and hence we have a lower centralization score. In IPv4, obviously, due to exhaustion, we cannot have newer delegations. Although the trends look stable at a continent level at a macro scale, when we look into country level, certain countries show an increase in centralization over time. And this happens not only in V6, but also in V4, interestingly. So I studied some of the organizations individually, and the reason why the centralization of the addresses increased turns out every time a new player enters a specific country and they acquire a lot of addresses via transfers, or in IPv6, it can be new allocations also. And once they start routing these addresses, the centralization scores show a strong jump. More closer look is needed into what are other trends and explanations into why centralization is increasing over time. And this is a work which is currently in progress. Now we saw the centralization at the IP layer. So how does this result and centralization metrics that we saw here compare with other layers? Prior work has looked into the centralization of the hosting provider ecosystem, the paper in SIGCOMM 2025. They had a similar finding where they identified that countries in North and East Africa have a high centralization. So it's true for the hosting provider ecosystem and also true at the IP layer. Similarly, the work in PAM 2022, which is looking into AS and transit influence, found that countries like Ethiopia, Cuba, Libya, they overwhelmingly rely on state-operated infrastructure. They only rely on the state for access to internet. And even in our case, we see a high degree of centralization in Yemen and Cuba. So in these specific countries, centralization is not only at a single layer, but it's happening across multiple layers. And to develop a more resilient internet ecosystem, centralization has to be studied across these layers. Interestingly, in other cases, like Turkmenistan shows a low DNS and TLD centralization, but we see a very high degree of IP centralization. Countries in Eastern Europe, like Belarus, Latvia, they have a lower than average DNS and TLD centralization, but in terms of IP, they have a higher than average, and especially they have a high centralization in that specific region. This shows that we cannot isolate the centralization studies into web and other layers, but studying the IP layer can give us more detailed insights. So some of the key takeaways. IPv4 ecosystem, we saw that it's more centralized than V6, and state-owned organizations are dominating countries with high centralization. In IPv6 ecosystem, the absolute numbers of the centralization score, they are lower. And one explanation is obviously the easy allocation of V6 ecosystem. We observed organizations which show regional presence, and they have presence and a dominating influence not only in a single country, but across countries. We saw this phenomenon in Central Africa, Caribbean, Northern Europe, and also in Central America. And we also observed how countries exhibit centralization across multiple layers. So I'm already looking into, obviously not all IPs are the same. Right now, I'm looking into the prefix level traffic information. So I'm expecting to get insights into which IPs carry a vast amount of traffic and which end user organizations are responsible for deploying services which is resulting in this traffic. And I'm ready to take any questions, and feel free to email me or contact me in any way. I'm open to any questions and feedback.
Thank you, Deepak. Your presentation was very clear and crisp. Let's see if we have questions.
Thank you.
Hi, this is Alex Amaro from UC Davis. Great presentation. Hi. 2 questions. One is, can you talk more about this cross-layer centralization? Because it was only briefly introduced. Maybe it's in progress, but it's very interesting. And then the second question is, when you disaggregate like an address space that's been redelegated, that gives you like a lower bound, right? Because often the address spaces will not be formally redelegated. And so you'll have Comcast has like this huge address block, which is obviously not all Comcast customers. So I was wondering if you had some thoughts about that as well.
Yeah, so the first question about the cross-layer centralization. This is actually a work in progress, and I was actually looking into related work, and PIMFspain is obviously your paper. And that is actually looking into the ASN ecosystem, and my motivation of looking into IP layer and not just ASN is because a lot of organizations, as I was mentioning, the cloud innovation part, they don't even manage an ASN, so they don't show up in the BGP layer. That's why I was interested into looking into the IP layer. And I also have some sort of commonalities into certain countries, just like I mentioned, Cuba, Libya, Yemen. But I'm expecting to get more insights once I also look into the traffic information. And I am also comparing with the web domains that has been done in the SIGCOMM papers. I still don't have all of the metrics that I would like to have, but definitely I'm interested in doing a lot more work and understanding for a given country at a different level how the ecosystem differs. Regarding the other question about addresses which have been redelegated, for example, you're mentioning one large IPv4 allocation can be Comcast, and they might have different other organizations or like customer organization. In this case, the prefix swap data actually mentions for this large block of address which organization has the direct allocation, and direct allocations, obviously, they do not overlap. An RIR gives one direct allocation to one organization, and this organization, say Comcast, can do further redelegations to their customers. So all of the centralization scores that I compute over here are measured on the direct allocations, and they don't overlap with other organizations. And the reason why I did it on the basis of direct allocation is because these are the authoritative organizations, the organizations which are holding these direct allocations. These are the authoritative organizations who are in fact responsible of offering connectivity. So they decide how my customers should get connectivity. So if I am giving a reallocation to a customer, I should be the one who is the upstream provider. These kind of constraints are placed by the RIRs themselves. It's totally up to these organizations with direct allocation as to how they should provide connectivity. And they're also responsible for fair distribution of resources among their customers. So this is the reason why I chose to do it based on the direct allocation organizations. But definitely, I would want to look into when I start looking at the traffic level information and the services, I would want to take a look into the end user organizations who also play a critical role.
Okay. Thank you, Deepak.
Yeah. Thanks for the question.
I think we will stop here for questions because we have lunch afterwards. So you don't want to eat too much into lunch. Thank you, Deepak, for your presentation and staying up late again.
Yeah, definitely.
Much appreciated.
Thanks a lot.